Hi, everybody. Welcome. Thanks for coming. I'm actually quite surprised how many of you showed up. Continuous integration, which I thought was like a niche topic that not so many people were interested in, and there were only a few people on each team that really care about the CI server, and here I have like full room of people. So thanks for coming, and I really appreciate that you care about this topic because it's a topic that is really important for me because I built our CI server, and I'm happy that I'm able to share all my findings with you in this way. So for those of you that don't know me, my name is Igor. I'm the team lead on the AngularJS project. And as I mentioned, I built the ci.angularjs.org, the server that we use for continuous integration of AngularJS. Oh. Yeah, just a sec. Okay, there we go. Okay, so what is continuous integration? Would anybody like to try? No, not you. So just for those of you that don't know, we have Kashuke from CloudBees and the founder of Jenkins and Hudson in the audience. So he's overqualified to answer this question. So anybody else wants to try? We're here.
It's so you know who to blame when they break the build.
It's so that you know who to blame when they break the build. That's very accurate, actually. There's more to it, but that's part of it. So let's stick to that. So for me, this continuous integration is our development practice that allows us to prevent integration hell. Integration hell is what happens when you have all these branches of the development going on, and eventually you just need to merge them all together, and now you realize that the differences are so big that you don't even know where to start to integrate all the software. So instead, what we can do is we can just have a mainline development branch that everybody syncs to and pushes all these changes to very often. And very often, I mean several times a day. But it also allows you to build trust in this mainline development branch. Because by working with it all the time, trust against this mainline development branch, you know that it's a piece of code that actually works, that you can rely on it. Because the last is to build software on a really rotten foundations. Like, I'm sure you've been there where you were on this new project and the team was very junior and they didn't know what they were doing and they were like just pushing all these commits to the repository, and now you were in the middle of something and you needed some changes, some fixes that somebody on your team did. Now everything's broken, like the application doesn't even build. Like that's exactly what we're trying to prevent. We want the mainline development branch to be stable and to be able to trust and work with it. So there are several other, like one of them is that by running these continuous checks against the mainline development branch, we are actually keeping all the team members honest about what they are committing. There are some people that look really cute, have really nice smile, but they can break code. And like, this is not that they are evil or they don't know what they're doing, but I'm sure you've been in a situation where you were making a single line change in the code base and you were thinking like, there is no way this can break anything. Like, I can just commit this and push it to production and everything's. You do it, and 5 minutes later, you're getting these calls that the application doesn't even start, like all the servers are crashing. And then you look at it like, oh, yeah, if I ran my tests and if I did everything properly, this wouldn't have happened. So this is one of the things that we're trying to prevent with integration. Then with web development, we have another issue that we're trying to solve, which is cross-browser testing. Like, we have all these browsers that we are building an application for, and we want to make sure that the application runs into all these browsers. But for us as developers, it's really hard to test the application in all the browsers all the time and like make sure that it just works. It's good to have access to all these browsers on your local development machine, but you don't want to continuously run all the tests on all the browsers. So this is something that the CI server can do for you. It can have all these browsers available and just run all the tests, and it's probably going to take longer than what it would on your local machine when you just have one browser. But who cares? It's just a machine that is just doing its work. And lastly, once you have continuous integration, it allows you to do fun things like continuous deployment. How many of you know what continuous deployment is and actually do it? Several hands. So for those of you who don't know, continuous deployment is about pushing all the pushing all the changes that were merged into the mainline development branch to production as soon as they pass all the checks. So what you do is you develop, you build a single feature, it passes all tests, you merge into the mainline, and you push it to production right away. This is not something you would do for a desktop application or for a mobile native application, but it's very suitable for web applications where like many of the startups or many of the even teams here at Google, they really want to get all the changes out to the clients as soon as possible, so they are not sitting on this pile of features that nobody can use. They want to get the feedback from users as soon as possible. And continuous integration is something that allows you to get here, to do continuous deployment. And we actually use this to deploy documentation. So I don't think many of you know, but the documentation that is on docs.angularjs.org is generated from the source code. And what we actually do is we run a build on a CI server, and every time there's a doc update in the stable branch and all the tests pass on the CI server, the CI server will actually deploy the new version of docs so that we don't have to wait until the next time we cut a release, and that way we can get all the doc updates out as soon as possible. There are some prerequisites that you have to fulfill in order to do continuous integration. One of them is you need a test suite. Like you need to be able to run something. So test suite is something that you need to have. You need to have a local testing story, and I cannot emphasize this more. You always should start locally, like start on your local machine, make the development environment as good as possible, make it really productive, and make it suitable for you. And once you have this, and once you're happy with your local development environment, then figure out how to do the CI integration and how to do all this other stuff. Don't do it the other way around. Relying on the CI server to catch all the errors and just run the tests on the CI server is too late. You want the feedback from running tests as soon as possible. And lastly, you need source control management system, Git, SVN, Mercurial, whatever you have. I think everybody here uses that already, and if you don't, I don't know what you're doing here. I'm not going to look if you feel ashamed right now, but you should be using source control management system. So let's talk about our test suite. We use Jasmine to write the tests that we run. So Jasmine is the DSL, the domain-specific language we use to write our tests in. We don't actually use Jasmine Runner to, I'll show you. We don't use the traditional way of running Jasmine tests. We have our own test runner that we built. But a test suite is about over 1,800 unit tests that are written in Jasmine. And then we have about 220 end-to-end tests, which check the entire stack of Angular and make sure that it actually works with the real applications. And these tests are written in Jasmine-like syntax with something we call Angular scenario or Angular end-to-end runner. It's something we created for Angular. And we run all of these tests twice. We run them with jQuery and without jQuery. Because you probably know that Angular has optional dependency on jQuery. It can work with jQuery if it's available, or it can work without jQuery. So if you have jQuery, we're just going to use it, and you get some performance improvements and stuff that jQuery is really good at. If you're building something smaller and jQuery is too heavyweight for you, you don't have to use it. Like we have a way of working without jQuery. And we run all of the tests currently on 8 browsers. And the most important thing is that our build takes about 7 to 8 minutes. So to run all these tests twice on 8 browsers, build everything, make sure everything works, render graphs, and do all that work, is about 7 to 8 minutes, which is very, very nice, considering the amount of work that needs to happen to get here. But even more importantly, the local story is even better. For local story, you really care about the unit tests, because those are the tests that are really fast to execute and can give you immediate feedback. And we can run those tests in 3 seconds. So what we do is every time we save a file in Angular, we rerun the entire test suite and see if we broke something or not. Let me show you how this works, and then we go about talking about how we build out the entire system. So I have my favorite IDE open, and as I mentioned, we have a test written in Jasmine. So on right-hand side, I have a test for some component in Angular written in Jasmine, and on the right-hand side, on the left-hand side, I have the source of the code that I'm testing. And this is my typical environment where I have the source code and test code side by side. And down here, I have output from the test runner, which I'm going to stop just to show you what it looks like when I start. So I'm going to start my test runner. I have a button in WebStorm which just triggers a shell script to start Testacular, a test runner. And what we see, there is an output. And this output just says, hey, Testacular started. It started on some URL and some port. It captured Chrome. So if I look, there is new Chrome instance. This is a different instance than the one I'm typically using for browsing and checking my email and doing stuff. This one has a separate profile and is completely isolated. And it executed all the tests in 3.9 seconds. So it was a little longer this time. But what is more important, if I go and change something, I'm just going to make bogus changes here. You see that the test run detected the changes and reran the entire test suite. So I'm rerunning the entire test suite, and now I see everything still passes because I didn't do anything horrible to it. So that's the local development story, and this is why I'm really proud of all the effort we put into building this local development story, because it makes us super productive. So let's say that I made some changes and I'm happy with them, and now I want to push them to the GitHub repository so that it's reviewed and merged. So I would just go to my command line. I would just do git add -b review. Yeah, that's good. Git commit. And this is just some demo commit. OK, I made a commit. Now, if I go to my browser, there's Jenkins server running here. It's at ci.angularjs.org. You see a whole bunch of jobs that are here set up. And right now, there's nothing happening on this server. It's quiet. But what I'm going to do is I'm going to do git push origin and demo branch. So I'm going to push a new change. And we'll see that Jenkins will soon detect this change. And more importantly, this is a window. This is a VNC session to the CI server. And what you'll see soon is that all these browsers will just pop up and will do work and will shut down and will start up again and will do work and go back again. And what is happening here is Jenkins detected that there was a change, or actually GitHub detected that there was a change. It sent a ping to Jenkins and told it, hey, there are new changes in this branch. Jenkins detected that, hey, I have a job set up that is observing this repository, and I need to check out the changes and do some work. So it checks out all the changes, and it starts the build. And during the build, it will build Angular, and it will start all these browsers. It will start unit tests. And if I look at the console log, you see that there are all these dots, and each dot represents a test that passed. So it already executed a whole bunch of stuff. We have all these browsers. We have Chrome, Chrome Canary, Firefox, Opera, Safari, IE8, IE9. And it's right now we're waiting for IE8, which is very typical, unfortunately. And it's just amazing. I didn't have to do anything. I just pushed it to GitHub, and now it's doing its work. And if I screwed up, if I made some mistake, because maybe I didn't test on IE on my local server, in a few minutes, I'll get an email saying, hey, this test is failing on IE. You need to go back and fix it. So this is our CI server demo. Yeah, now it's running probably the tests with jQuery or without jQuery. I don't know which one is it now. But it's just going to, every time it needs to run the test within a different mode, it will just shut down the browsers and bring them up again. And one thing you can see is that we have these virtual machines. I have Windows 7 virtual machine, which is running IE9. And I have Windows XP virtual machine, which is running IE8. And you just seamlessly works. Like, I didn't have to do anything. Everything is configured to just run the tests in all the browsers. And just today, we actually added even an Android emulator, so we can run tests in Android browser as well. The emulator is quite slow, so it's not part of the main job. There is a different job that is triggered once this main job passes, and that will run the test in Android. Any questions about this? Or should we go and talk about how is all of this set up?
Does Testacular gives you all of coverage as well?
Does Testacular give you code coverage as well? The answer is yes.
Okay.
You need to install some modules. Vojta over there is actually author of Testacular. He wrote most of the code. If you have questions about that, you can just catch him after the talk.
I was kind of wondering that if you don't write tests at all, you can check in your code without breaking your unit tests, right? So unless you have some measure, such as code coverage.
So this keeps on coming up. 100% test coverage is the number you want. Anything less than that is not good. Anything more than that is impossible to achieve. And 100% test coverage is not good enough to tell you that the code actually works. So there is some value to code coverage, but I wouldn't give too much value to it, because what you want is assertion coverage.
Yeah, so other than code coverage, what could be the better alternatives to measure your unit tests?
So I think you need a bunch of stuff. Code coverage helps. Like we don't do code coverage because we just do really thorough code reviews.
Sure.
I think code reviews are more telling than the actual code coverage, but it depends on the team. There is no perfect answer right now, but
so in our case, we are maintaining currently. It's a true story. We are maintaining about 97% of code coverage, and if somebody checks in the code without a unit test, it breaks the CI, so that we know who didn't check in their unit tests. That's one way to kind of force team members to write unit tests.
Yeah, but again, the test coverage is something else than assertion coverage.
Yeah, I totally agree with that, but you need something though, right?
Right, yeah. It's a number that helps, but it's not something you should be really tied to.
I agree.
Thank you. So let's talk about how all this craziness was set up. But before we do that, let's talk about how did we get here. So Angular CI/CD 9. So in 2009 was the year when I joined Miško on this adventure of building AngularJS. And back then, this was our CI server. So this is a photo of Miško's living room. And under his TV, there's the little box. If you can see, that's a Mac Mini under his TV. And that was our CI server. It was running in Miško's living room, literally. Like, I'm not making this up. It had only 3 browsers. And it was very slow because it was running in a virtual machine. So he had a virtual machine, Windows XP that had Firefox, Chrome, and IE 6 or something. I don't know back then what it was running there. So we had just 3 browsers. It was super slow, and we were using JS Test Driver, which is a test runner that we used to use for a long time before we created Testacular. And JS Test Driver was very flaky, and like the whole combination of all of this was very flaky. And it got to the point where one day, Miško's cleaning lady came to his house, and she was like doing really thorough cleaning and pushing buttons, and she like unplugged something, and a CI server disappeared. Like we couldn't access it, and like what's going on? And we were just without a CI server for the whole day until Miško got home, and then he looked at it and like, oh yeah, this thing is unplugged. I need to plug it back in. And that was like the point where we were like, this is enough. Like we have to do something serious because this is a very important piece of infrastructure for us to make Angular, and we cannot be relying on such a flaky thing. So we started thinking about what are the key features of the CI server that we want, and we defined 3. So one was speed. Like we wanted the tests to run as fast as possible. Because previously it was just taking too long, and like we needed to know if the code is good or not as soon as possible. We needed it to be reliable. Like we didn't want flakiness. Before, it was very common to get a broken build when there was actually nothing broken. It was just like the browser didn't start up, or the VM was crashed, or something happened. or JSTD just had a bad day. There were many things, and we just needed to know if the problem was in the code or if the problem was in the infrastructure, and there was no easy to tell. And lastly, we needed a better access to browsers, to a wide variety of browsers, because Angular is used on many browsers, on Safari, on Chrome, on Firefox, Opera, you name it. And we need to be able to run tests on all these browsers so we can tell, yes, this works, or no, this doesn't work. Or even debug stuff, like if you don't have the browser and there's a browser-specific issue, you have no way of fixing that issue. So that's when we started to face many decisions and trade-offs. And it wasn't easy. Like building the CI server was not something that happened overnight or over a week, over a month. It took us months to get to the point where we are now today. And one of the first decisions we needed to make back in 2009 was to cloud or not to cloud, to use cloud provider for our CI server, or to build our own dedicated server. And back then, we decided to go with a dedicated server, because in 2009, there wasn't really a good story in the cloud. Like cloud bees were starting, browser stack was non-existent. Like none of this infrastructure that we have today didn't exist back then. So the only option back then was just to build a dedicated server for us. And this is the architecture that we came up with. So first of all, you need some hardware to run this. And on top of the hardware, you need some operating system. And within the operating system, you need some kind of CI application server or CI server that provides you web interface and watches repositories and triggers all the builds. None of the CI servers back then or even today had a good support for JavaScript testing. So in addition to the CI server, you also need some kind of test runner, JavaScript test runner or harness. And this test runner must be able to start a browser and run tests in a browser. Like we don't want a Phantom.js, or we don't want some kind of fake pretend browser. We want the real browser that people actually use, because all this, like even with IE and compatibility mode, many people develop in compatibility mode and then claim that their website is IE8 compatible. But it's not, because IE9 and IE8 compatibility mode is a completely different browser with completely new bugs and quirks. So we want the actual browser that people use. And more, even better, we don't want just one browser. We want lots of browsers. So this test runner must be able to have access to lots of browsers. So let's talk about hardware and how we made the decision. It was actually quite easy. We picked Mac Mini Server primarily because we need to be able to run Safari. And if you want to be able to run Safari, you need macOS. And macOS runs only on Apple hardware unless you're doing something illegal. So Mac hardware was the only option for us. It was quite good option because Mac mini servers are quite powerful. Like if you look at the specs, they are really nice machines. And they're also cheap to host in colos. If you just Google for Mac mini colo, you'll find several providers that will just either sell you Mac mini, or you can just ship your Mac mini server to them and they'll just plug it in, host it for you. So the specification that we end up with was 2 gigahertz quad-core Intel Core i7 machine, which is quite beefy one if you don't know. And we got lots of RAM. We got 16 gigs, which is I think the max you can get right now for this class of Mac mini servers. RAM is cheap. If you're building your CI server, get as much as you can fit into that machine. Also, we started with a disk that was not SSD, and I think it was like half a year ago we switched to SSD disk. And it made a huge difference because you're dealing with virtual machines, you're dealing with all this stuff that just comes and goes, and lots of logs, and like SSD is a perfect use case to use here. And also get an external drive, which you can use for backups, because you do want to back up your server. Because if you lose it, you are screwed, and it takes forever to rebuild it. So I actually was lucky enough that I had a backup when something bad happened to our server, and I was able to just recover. So it's a really important thing. Question? Do you use, hold on, time machine, wait. Do you use time machine? I'll get to that. Yes, in addition to something else, but we'll get to that.
How do you do? This is
Joke. Try again.
test, test.
No.
Hello? What's going on? Am I not loud enough? Hello.
This one's on. We have to use the microphone.
Why?
Well, there are people on the
Oh, okay. How do you guys deal with mobile testing? Because
mobile testing.
yeah, like if you were running it on, there's like tons of different Androids. There's tons of different versions of mobile Safari, mobile Chrome, old browser, and devices.
So to truthfully answer a question, we didn't care, or we didn't. Not that we didn't care. We didn't set up any kind of mobile story until like last week when I was thinking, well, I'm going to present the CI server, and it's going to be really bad if we have no mobile browsers there. So we worked hard, and we now have, as I showed you, Android browser set up. We're working on Chrome, and we also want iOS browsers. Like, it's not super difficult to set everything up. It's just a matter of figuring out what works, what doesn't, and it just takes a long time. So, but once you know the recipe, then it's easy to replicate. So we have the recipe for Android browser now. We're working on Android Chrome, or Chrome from Android, and we also on iOS. We want to use emulators right now, just because it's easier to just spin up a new VM and just change the specification. It's slower than a real thing, but right now it's not really feasible for us to be shipping actual devices and plugging them to the server. Like, we might do that in the future, but right now the emulator is good enough. Thanks. So some tips about the hardware and the Mac Mini server. What you want to make sure is that the server comes on when the power is available. Like, the last thing you want is for there to be a power outage, and the server shuts down, and the power comes back on, and the server is still down because it's waiting for you to push the button. Like, it's a Mac Mini, and especially if you don't get the Mac Mini server, it might have wrong default settings. So just make sure that it comes on after the power is available. It's also good to have UPS, uninterrupted power supply, or some kind of other remote power management system so that you can restart the server if it's completely, like if it's a remote server, this is something good in case something goes terribly wrong and you're locked out of the machine and you need to restart it. And lastly, you'll need a fake monitor, and this is something that I'll come back to later and explain. Operating system. So with Mac hardware, OS X is the only reasonable choice. And we're using currently the latest one. We used some older versions before, but right now we have 10.8 Mountain Lion. And the main reason, because we need to run Safari. Like, we want Safari, and OS X is the only option to get it. It's Unixy, so it's not a bad. Oh, Koshika has.
This is the second time you mentioned that the Safari requires macOS, but what's wrong with Safari on Windows?
Well, Apple announced that they are not going to continue development of it, and also I don't trust Safari on Windows to be the same as Safari on Mac. Like, I had plenty of bad experience with these kind of differences between platforms to know that I want the real thing.
It seems like you went through quite a bit of suffering to on OS X, and if you're using quote-unquote real operating system.
Real operating system.
Yeah.
I don't know.
Just saying,
like,
I'm sorry, just saying.
It's just one of those decisions and trade-offs we had to make. And like, the other option would be to run macOS in a virtual machine. But even then, if you read, according to what I read in the licensing terms from Apple, you still have to run the virtual machine on Mac hardware. So you could run Linux on Mac hardware and have a virtual machine that runs macOS so that you get Safari. But that's just a little too crazy. So that's why we just settled on OS X. It was just easier. So it's Unixy. It's Linux or Solaris or whatever is your favorite operating system. But it's good enough. It's good enough. It has good tool support, so we feel pretty comfortable there. It's definitely much better than Windows, like miles and miles better. Some tips, again, just make sure that the power management is set up to start up the server after power failure. you want to turn on the firewall and turn off everything else, like Wi-Fi, Bluetooth, infrared receiver. I don't know what else is there. And also any kind of unnecessary services. Like you don't want what is it, Apple file sharing and Bonjour and all this stuff running there, because it's just going to confuse things, and it's just going to create more vectors for anybody to get into the server. Also, what we found out the hard way is you want to tweak the Spotlight settings, because Spotlight will index everything and will reindex everything as you change file system. And on a CS server, there is a lot of churn on the file system. Like you constantly are just reading files and writing logs and writing build artifacts. This doesn't need to be indexed. So you can just go to the Spotlight preferences and just tweak it so that it really indexes only stuff that you care about. And often you can even disable it completely. So this is a screen from the VNC session that I have. If you can't read everything, don't worry. The slides are going to be available after the talk, so you can just see all the details. But just some important points. The Jenkins account that we have is a standard account. You don't want admin account to just run all the stuff. The guest account is disabled. We also have Mentimeters installed. So Mentimeters is this really nice tool which is free and allows you to just get visibility into the CPU utilization, the RAM utilization, and all these performance metrics of the server, so that you just know what's happening on the server. And I commonly not only SSH to the server, but also do a VNC session just to see what the browsers are doing. And this helps to see, like, yeah, the CPU is really busy, or CPU is doing nothing, so there is some bug and something stuck. The next thing is you want to use the Jenkins account as the primary account and log into that account when the server starts. Like, you could run some of the browsers in XVFB, X Windows Virtual Frame Buffer, but it's not ideal. There are issues with it, and especially with all the tweaking and debugging we had to do, having a VNC access and seeing what the browser was actually doing was super helpful for us. Another tip, use solid background. It really speeds up your VNC session. Don't put any kind of fancy pictures of your family. Do that on your local machine. And then it was mentioned backups. So we have actually the external drives is partitioned into two partitions, and we use Spotlight as well as SuperDuper to back up the drive, so that we have a bootable backup. And in case of really big disaster, we can just swap the drive and keep going with the last backup. Let's talk about browsers, because that's where all our tests are running. So we have Chrome, and we have Chrome Canary, among other things. And these are the browsers that are very easy to use, because Testacular has a native support for these browsers. And you can just use -- browsers, Chrome, Chrome Canary, and Testacular will just start these browsers with an empty profile, and will execute all the tests, and at the end it will just clean up all the mess so that you don't have to worry about it. So I'm pretty happy about these two browsers. Let's talk about Safari. That one wasn't that easy to use, especially because Safari has no notion of profiles. There is just one profile, which is your user profile. And you cannot just create a profile and use that. So any kind of state that is left over from the previous session will be available in the next session. And also, unfortunately, for whatever reason, Apple decided that they are not going to give you a command line interface to Safari. So you can't just easily use Safari to open any kind of arbitrary URL, which kind of sucks, because that's what we need a test runner to do. So we had to figure out some hacks how to trick Safari into opening this URL that we wanted it to start. And we created a Safari.sh script that we use. And what it does, it starts Safari with a particular URL, and at the end of the run, it will shut down this browser, and it will delete all the resume state and all the session state that was associated with running that browser. So then we have Firefox and Opera. And again, these are browsers that have native support in Testacular, and you can just do dash browsers, Firefox, and Opera. With Opera, there were some tricks that we had to figure out, and we actually worked with the Opera team, and they even sent us pull requests, which I'm really grateful for, because they helped us figure out several big issues that we were having with Opera. So Firefox and Opera work really well and are really easy to use. Again, I'm super happy about these browsers. And then we have I and i9. So, of course, you can run them natively in macOS, so you need the virtual machine. And to run them in the virtual machine, right now we use VMware Fusion. And we created these scripts, we call them i8sh and i9sh. And what they do is, from the host operating system, they go into the guest operating system, start the browser with this URL, and once the browser connects loads the URL, it will connect to Testacular, and then Testacular can run all the tests in the browser. And at the end, when Testacular tries to kill this script will relay the kill command into the VM and will shut down the browser. So we have these shell scripts that help us do things in the VM. And again, they help us start the browser, point them to Testacular URL, and Testacular can then execute all the tests in these. And at the end, it will just shut down the browsers. So virtual machines. We use, as I mentioned, VMware Fusion. We used to use VirtualBox for a long time just because it was open source, and I really like open source software, and when I can, I use it. But unfortunately, it was just too painful to use. It was full of bugs. It was crashing on us all the time. It was just causing too many problems. So one day, I was like, OK, this is enough. Let's just try to pay for a license and see. And it's not free, but it's totally worth the money, because it solved all the problems that we were having. And I'm very happy with VMware Fusion. Some tips about how to set up the VMs. I created a global virtual network adapter, which I attached all the VMs to. And this adapter is in this special mode that allows the VMs to connect only to the host operating system, but not to the internet. So this means that all these Windows virtual machines can connect to my Testacular server running in the host operating system, but can go further to internet, and I don't need to worry about viruses and malware and all this stuff. So I really like this setup, because I don't need them to go to internet. Give all the VMs plenty of RAM. We use 1 gig per VM. If you use less, your performance will suffer, and everything just takes longer. And really utilize snapshotting. So both VirtualBox as well as VMware have this feature where you can just take a snapshot of a running VM and then restore to that snapshot. And this is super useful, because if a server, it even speeds up the bootstrapping of the entire server, because restoring VM to the state of the snapshot is much faster than starting a brand new VM and having it boot into the operating system and log in and do all this stuff. That can take easily minutes, depending on the VM and the hardware you have. But with just restoring to a known snapshot where the operating system is already running, that's a matter of like 3 seconds or 4 seconds. So I really recommend it. And it also means that if something bad happens to the VM, you can just go back and go to the state where the VM was in a good state and everything was working properly. There are some command line tools, most importantly VM run, that you definitely want to use. And those are located in this really weird location that is not intuitive. So you might want to put that path on that directory on your path so that you have easy access to these tools and can interact with the virtual machines. And then we have Android browser, which, as I mentioned, we just recently added to our CI server. And what we did there, we just used the Android development tools to create an emulator with some sane settings. It behaves like Nexus device, and we used x86 image with GPU acceleration, which makes the emulator run faster than the default settings. So there are some things that you can do to speed up the emulator, but it's definitely going to be one of those slower browsers that you'll use on your CI server, which is fine. You probably don't want to have it in the main pool of browsers, but have it in like secondary pool that you'll test against once the primary pool succeeds. And we created this Android.sh script that allows us to do the same thing as with IE, just dispatch commands into the emulator, start the browser, and shut it down at the end of the test run. Test runner. So I mentioned that we started with JS Test Driver. We're not happy. We tried to improve it, and we worked with a developer who was working on JS Test Driver. But after a while, we just realized that the issues were just architectural flaws that couldn't be just fixed by patching JS Test Driver. And that's why I talked to Vojta, and I was like, Vojta, I have a really cool project for you. You need to build a test runner for us. And back then, he didn't know that I was a sneaky guy, and he was like, that sounds good, and he started working on it, and today we have a really awesome test runner, and I'm really happy that Vojta accepted my challenge back then. So we use Testacular, which is a node-based server, so you'll need Node.js on the server with NPM. In order to make NPM easier on the server, you want to chmod the user local directory with the current user, so you don't have to use sudo over and over whenever you need to install NPM. And ideally, you want to install Testacular in a non-global location, because then you can have different versions of Testacular running for different jobs, depending on whatever the current job or project that job represents is using. There are some interesting flags that you might want to use. One is a single run, which means that after running all the tests, Testacular should shut down and not listen for file system changes, which is the default mode. Then we have some reporters, dots and JUnit. Dots represents those dots that you see in the log. That's not the default reporter, but dots is what you want to use on the CS server when you are storing logs. And JUnit will just reproduce will create an XML file, which you can then feed to Jenkins, and Jenkins can just give you a nice table of results. And last one is no colors. It just makes the logs look better. You don't have all these escape sequences in there. So let's talk about the CI server. We picked Jenkins mainly because it's something that I used before. Everybody was comfortable with it. It's an open source project, and we didn't have reason to go elsewhere. Some tips. When you're starting Jenkins, you want it to listen on the local host only, so that you can then decide how it should be represented to the external world, or how it should be accessed by the external world. And what we do is we just have a proxy that will do HTTPS proxy for this server, so that there is a little more security. And we use a single executor, and this is an artifact of using an interactive session of the operating system. Since you can start the browsers really just once, some browsers like Safari can run only once reliably. We just have a single executor, which means that we run only one test at a time, or one job at a time. But within this job, we run all the tests across all the browsers in parallel. So this means that if you have many developers working on a team and they commit changes, there will be a queue of things that the test server need to go through. But in our team is relatively small, so it's not a big deal, and we never have to wait for anything. So we use single executor. Some notable plugins that we use Git and GitHub plugins that allows us to set up the jobs easily. We use plot plugins for some graphs, and we use Greenballs plugin to make green builds green and not blue. We need to talk about that. So our job setup, we have one job on Jenkins per developer. So each developer has its own job that watches his private repository on GitHub and watches all branches. So no matter which branch you push to, Jenkins will see the change and will check out that branch and will build it, and you'll see. Then we have an upstream master job, which watches just the upstream master branch and builds that one. And we have an upstream V10X branch, which is our stable branch, and that's something that we also test against. And then we have a whole bunch of random jobs that we just use to test other related projects to Angular. I have some screenshots with some settings of how we set up all the jobs. You're probably not going to be able to read it, but again, you'll have access to slides later. So let me just fly through this, and you can look at it in detail later. So when you're setting up a job, you just need to tell it where is the repository that it needs to watch, and what are the branches that it needs to watch. In this build, this is my own job, and I have it set up to watch all the branches. Then we have triggers. So Jenkins needs to know when to run a build. And there are two ways to do it. One is polling. So Jenkins will check on GitHub and see if there are any changes. That's what we do as a fallback. But we also have a GitHub webhook set up. So if you go to GitHub, the admin interface of your account, you can actually set up this hook and point it to the CI server. And what will happen is that GitHub will proactively contact the CI server and tell it, hey, something changed. And that way, you don't have to wait until the next poll occurs and you get the build triggered faster. You definitely want to abort stuck builds. This is something that I learned the hard way. We didn't have this, and something went wrong, and the build was just stuck. And all these other jobs that other developers triggered were just queued up because we didn't have this abort stuck build setting. And Jenkins actually doesn't do much in terms of running the tests. It just triggers a shell script to be executed. So we source a shell script that is shared between all the developers. And that's a good thing, because then you have just one shell script to change when you need Jenkins to build something, when you need to make changes to the build. So you just go to this shell script, and all the developers will get the changes. And we source the shell script instead of just executing it, so that all the output from the shell script is logged in the Jenkins log. So there are some more settings, like archive artifacts, like you want to have the build artifacts preserved so that you can just use JSFiddle with this new builds. And we gather some data to create graphs. We mainly use that to check the size of Angular, because we don't want it to be too big. So we have graphs that show, yeah, the Angular is getting fatter, or it's on a reduction diet. Some of the last settings is we generate JUnit. We consume JUnit reports that Testacular generated, and this is something that you can then use in the UI to get a table of all the test results and see, yes, IE8 is the slowest browser, and you see if there are any failures, if they are specific to a browser or if they fail across all browsers. And of course, you want to get an email if you screw up, and there is a setting for that. So to bootstrap the whole system, we use launch agents. This is something macOS specific. Once the default user logs in, these are like scripts that will be triggered. And it's a little more sophisticated than just scripts. But we have these plist files which start Jenkins and will also start all the VMs. So we start the VMs only once at the start of the server, and they keep running. And we just shut down, start up and shut down all the browsers within these VMs. But we don't actually shut down the VMs and restore them between each run, because we didn't find it necessary. Like, it's enough to just shut down the browsers. So to recap a solution, we have a Mac Mini server, which runs OS X. And we have VMware Fusion, which we use for virtualization primarily for Windows 7 and Windows XP. We also use Android development tools, which we use to create Android emulators. And we have Jenkins, which is our CI application server, which, when it notices a change on GitHub, will start Testacular. And Testacular, when it starts, it will start all these browsers. And we'll execute all the tests, and at the end, we'll shut them down. So that's our crazy setup that we have right now. As I mentioned, we want to add more browsers. Windows 8 and IE10 are on the way. as well as we want to figure out iOS. I expect that it shouldn't be too difficult, but after the experience with Safari, who knows? And hopefully we'll get Chrome also running. There are some issues with emulator and Chrome that we still need to figure out, but we're motivated to figure them out. So everything's good, and all of this is running, but all my browsers are stalling. Like, it takes forever for the build to run. What's wrong? And this is a situation I got into about half a year ago after we fixed like all the other major issues that were blocking us. And there was like nothing wrong that we could reproduce locally, but still on the Mac, everything was just slow. Especially Safari was fine. Like Safari was running perfectly, but Chrome, Firefox, Opera, they were just horribly slow, and sometimes they would just freeze and not do anything. And it just made no sense why this was happening until I got this hint that maybe because this monitor is not attached to the server is behaving differently. And it turns out that that was the fact. So in order to trick macOS server to give you full GPU acceleration, which Chrome, Firefox, and other browsers really need, you need to trick it into thinking that it's actually attached to a display. And the way you do it, you just get this dongle from Apple, which is ridiculously overcharged, and you get a very cheap resistor that you just plug into the right pins, and then you plug it into the macOS. And once you do that, everything is super fast. Everything is like beautiful. And it was guys from Mac Mini Colo who actually helped me to figure that out. And I'm really grateful for that, because I was ready to rebuild a server in my office because I just wanted to be able to just look at it and like punch it when it was slow. And and if I would have done that, it would work in my office because I would have the display attached to it. But then I would ship it to them to host it for me in the Colo, and they would not have the display, and it would be slow again. So I'm very glad that we figured this out before I rebuilt the server and went through all the trouble just to fail again. So there are some future plans we have. As I mentioned, we want more browsers. i10 is on the way. The Chrome on Android. We want iOS. We are looking at Sauce Labs and Browser Stack because they have now this really nice testing story. Like they have all these browsers in the cloud that you can use. We haven't figured out all the details, but I think it should be not that difficult to integrate with them and use their browsers to run our tests. It will be much slower than using our local browsers because our VM's already set up and ready to run. So I'm not interested in just throwing away all the setup we have because it's definitely much faster than what these guys can offer us. But for some of the less popular browsers that we don't want to go into the trouble of hosting and they're not in the primary pool of browsers that we test against, this might be an interesting option to just be able to just say, hey, I want this weird browser that nobody really uses, but there's this one guy who complains about bug in Angular on this browser. So to be able to have access to these browsers would be really interesting. And then if we need to, right now we don't have the need, but if we need to in the future, it would be nice to have more slaves so that we can parallelize builds and do more in parallel. But this is not a pressing need for us right now. And for pull request screening, right now we use Travis CI. If you don't know about Travis CI, it's another CI server in the cloud that is completely virtualized and can do interesting things for you. We use Travis CI for pull request screening. So if you send us a pull request, Travis CI will notice and will try to build it and will complain if your changes or if your pull request is breaking a build. So this is something we use to screen pull requests, but Travis CI has only 1 or 2 browsers. I think it's just Firefox and Phantom.js. So it's not good enough. And I just noticed when I was preparing for this presentation that there is a plugin for Jenkins called GitHub Pull Request Builder plugin. A little unfortunate name. But it does the same thing that we need that Travis does right now. So it will just watch GitHub and can check out pull requests and run build, and then send information back to GitHub to tell you that the pull request is breaking build or not. With that, you need to be careful not to allow people to just execute random code on your server. Like, you need to check what kind of, like, the strategy I would use is just whitelist which files you can change in your pull request before we can run the test on our CI server, because otherwise you could do bad things to our CI server. So, are you ready to build your own server? And if you are, I have a good news for you, because we're open sourcing all the scripts that we built. So you can go to this URL, GitHub Angular CI AngularJS.org. You'll find all the scripts that we use for starting browsers, shutting browsers, and all this crazy stuff that we had to figure out, and it was really painful. You can check it out. You can build your own server. And if you have suggestions, you can send pull requests to the repository. And just enjoy this. But there's one more thing. What if you could get most of our setup provisioned in the cloud with a single click? Would you like that? Well, I have a good news for you, because we were working with guys from CloudBees, and we have this setup. It doesn't have all the crazy combination of browsers that we have, but it's really just a single click away for you to get most of what we have. And you'll get tests running on Chrome and Firefox right now. But we are thinking of ways how we can provide more browsers. And with that, I would like to ask Koshuke to come here and give us a little demonstration of how that works.
Let's open another.
Oh.
Yeah, I think
Okay.
Yeah. So Igor was kind enough to let me demo this. So as he was saying, at Cloud, things we do is we have a hosted Jenkins service that you can use for free to up to a certain extent. And then one of the ways to get started there is called Quick Start. And thanks to Mike O'Neill, we have this AngularJS setup. So what we do is we just click this guy, and then it'll set up a series of stuff for us. So here, let me do like an Angular demo. The name doesn't really matter. And I say create app. And it's going to be fork I believe, the Angular seed applications. That's like a template stock app for running the Angular. And then set up a Jenkins CI job, and then complete with the running server environment. So if we go see it, we can see what it's doing. It's checking out the code. Well, actually, it's still waiting for this, the slave to materialize from the cloud. And
the clouds are forming right now.
Yes, the cloud is forming right now. But we can, in the meantime, see how this job is configured. It is basically just checking out from the Git repository. It's my copy of the Angular demo. I'm sorry, the Angular seed. And then running a little bit of the shell script to install the node and then do the build. So now it's I guess installing all the packages and then run the build. And then if this completes, we'll see, let me just skip forward to the running up. And then you'll be able to see the one that I launched earlier. I think this is the one. Sorry. I just wanted to get to the application. So this is the Angular seed app, I believe. That's running. And as you change the code through, we have the whole Git repository in the CI server and the running environment. So if you just make a change to the repository source code and commit to the repo, it will be built and tested, and then it gets deployed, so you'll be able to see the change right away here.
Right. So with a single click, what you're getting is you're getting a clone of Angular seed, which is a good enough way to just get started. You are getting a Jenkins set up and configured with a job for this repository. And you're also getting a deployment platform. Basically, the application, once built by Jenkins, is deployed, and you can go to a particular URL and see your application running. So you'll see your Angular application running. And all you have to do is just go to CloudBees and just enter your name. And as I mentioned, right now, we have in Firefox set up, but we are thinking of ways how we can bring more browsers on board. For small projects, this is very, very interesting and painless way to get started. Once you grow and you have more developers, more customers, and more browsers you need to test against, then you can start worrying about how do I bring all these other browsers on board and make sure. So yeah, the build succeeded.
I think it deployed at the very bottom.
Yeah, I'm just trying to show. This was installation of Node. Yeah, at the end we deployed. Somewhere here are the test runner logs, but it also gives you the table from. Oh yeah.
Yeah, so the test has run.
Yeah, so here's the test results. You see that we executed tests in all these browsers and everything's passing. So you can go check this out. It's free. Tell us if you like it, if it makes sense for us to continue development on this. It's all open source, so you can even contribute to all these templates and make it even better. With that, I'm happy to take any questions. And yeah, thank you.
Thank you. I have two questions. And the first one is, I saw that you were talking about the pull requests when you do them from GitHub. But when instead it's someone from the Angular team, and you want actually to merge a master or something like this, can you do that, or you have to do a pull request in Jenkins in order then, and then like some test is executed, and if all tests pass, then you're actually allowed to merge a master. Otherwise, you're not allowed to merge a master.
So this is not so much about the mechanics and how we set this up. This is more about the team culture and how we develop. And the rules we have is if you're making a change, this change has to be reviewed by somebody. So what you do is you create new development branch, you make the changes, you write tests for it, you get it all ready. You push it to your GitHub repository, your private GitHub repository. The CI/CD will notice because there is a job monitoring your GitHub repository, and will build this new branch, and will tell you if it's passing or not. If it is passing and everything is good, then we create a pull request out of that, have it reviewed by people, and once everybody's happy with the change, then it is merged into the master, where it is again checked by the CI/CD to make sure that after the merge, it still works the way we want it to merge. It works the way it wanted to work.
Okay, and I have a
All right.
You mentioned Gary, because some of the people who wanted to do what you're saying, they use server called Gary, which is another Google product.
So there is another server called Garrett, which is like a GitHub alternative that you can run locally. Correct me if that's wrong. And that allows you to do more of these, gives you more options.
Code reviewer. So you do Gary for review. People will look at the code, but also Jenkins will look at the code.
Okay, so with Garrett, you get the integration where you do the code reviews on Garrett, but Jenkins will also see the changes and will trigger a test run, and it will tell you if the test is. So this sounds very similar to the plugin that I mentioned for GitHub, where you can just observe pull request queue on GitHub and rerun yeah.
And then the second question is, I saw that in the future you would like to make some plugins from browser stack. And in this case, do you think that there is some difference, or like, is it better to run them in your own server, while instead, for example, just go browser stack for all different operating system browsers?
Right. So and I already kind of answered this during the talk. I think the current setup gives us many advantages over using browser stack for all the browsers. It's definitely much faster, and like you don't need to wait for the provisioning on the VM, and like there are many things that make it faster just because it's local, and like you don't pay the cost of the network traffic and all that stuff. But it's also a pain in the ass to set it up. So if you want to avoid that, and if you want to just get large amount of browsers or browsers that you care about with very little effort, it seems to me that right now, if I was starting this project today, I think I would more seriously look at the browser stack before looking at local VMs. But now that I have the local VMs and I figured out all these other things, I think the local VMs give us more advantages when it comes to speed and reliability of the setup.
Thank you.
We have some questions up front here.
Yeah, I've got a question as far as you use, why didn't you use like something like Selenium or others for that?
Why not use Selenium? That's a very good question. I actually should have mentioned this during the talk. Selenium is really good for end-to-end testing. So when you have like an integration tests that are very heavy, where you need to bootstrap your application server and you want to pretend that you are the user loading a page, clicking on the browser. And this is a category of tests that are very valuable, but also very slow to execute. We have some of them. We don't use Selenium for this purpose. We use our own solution. But we're actually thinking of improving our solution by building on top of Selenium, because there are many issues why we don't like Selenium. But more importantly, most of our test suite is composed of unit tests. These are very focused, small tests that test the components in isolation from the rest of the framework. Strictly speaking, they are a little more than unit tests, but it doesn't matter. Like I still consider them to be unit tests because they don't test the entire stack. They focus on particular API, particular service, or particular piece of Angular. And for these, Selenium is unsuitable. It just doesn't do the right thing there. So Jasmine is much better for this purpose. And Jasmine has its own test runner, which is HTML-based, which means that you have to craft this HTML page and load it in the browser, and the browser will run it, and then you'll see green or red in the browser. But it kind of sucks to automate this. And you could use Selenium to automate that, but then there are other issues. But what I really want to say is that we built Testacular so that we have a really good local development story. Like, we wanted to build a test server that allows us to run 1,800 tests in 3 seconds. Selenium will never, ever be able to do that. Like, it won't even come close. So that's why we built Testacular. And once we had Testacular, we wanted to make sure that we run the same tests on the CI server, so that there is no, like, oh, we're using this locally, but something else on the CI server, and now it's passing here and failing there, and now you have to figure out, like, what is the difference. So we wanted to use the same identical setup, except for the availability of browsers on the CI server. And that's why we went with this setup.
Let's go down the row here. We got a couple more. Yes.
Hi. Have you considered adding few like physical devices to the CS server, like a jailbroken iPhone and a Android device? Because it might sound complicated, but it's actually really easy to hook up that.
I know it's easy to do it, but because a server is hosted somewhere far, far away, it's not the most easiest solution for us right now. I don't think it would be a huge deal if I just told the guy at Make Mini Call that we need some devices plugged into the system. But right now we're trying to use these emulators mainly because the development is going so quickly forward, and then you have these devices that you need to maintain. Whereas with VMs, it's easy to just create a snapshot and recreate it if you need to, or create a new snapshot or a new configuration of the VM. So it just sounded like it would give us some advantages. It's still too early for us to tell if this is going to be our long-term solution because we just started with it. But it seems to be working okay right now. But who knows? Maybe we'll end up using hardware, like real devices for this testing.
Okay. Anyway, adding an iOS simulator, that's really easy to hook up.
Okay.
I can share some details later.
Okay. Just come to me, please, because I want to know.
Hello. So you mentioned that it's really important to have tests running, but do you have any frameworks to enforce styling of the coding, like naming conventions or loops? So sometimes you will be happy with the logic, but just to make sure that every developer, especially for pull requests, that everything is following certain patterns. Do you have any tools that you can install in CI?
Right now we don't. I would like to have something like that because there is it takes a while for developer to each team has some conventions that they use, and not all the time they are codified in some way, and then there are disputes, or the new developer comes on board and it takes them forever to get used to not using tabs, but using spaces and whatever you have. So we started as a small team, and as we are growing now, we start to feel the pressure on adding something like this to the build. And I think we'll end up adding JS hint, or we use Closure Compiler for minification of Angular. And Closure Compiler also has a way of checking and enforcing code conventions. So I haven't looked into this yet, but we'll need to figure this out. And I think it is valuable. Like if you're building.
Yeah, like as soon as you're growing up, I look for ramping up new developers. And I think like if you guys will be considering like pull requests, that will be extremely helpful for developers just coming on board and just contributing. Right, thanks.
Do you have any tools that you would suggest?
We are a .NET stack, so we're using StyleCop a lot. So
StyleCop. Is that a .NET specific?
I don't think it might be not just .NET specific, so they're probably branching out to the different tools.
Okay.
For JavaScript, we're using JSLint mostly. But StyleCop, so it does help, like, the rules, like, team own the rules. So, like, once we don't like something, we just can communicate with each other and say, like, yeah, let's drop this rule or let's enforce this rule because it's extremely helpful. But it does help to write, like, summaries and, like, just make sure the class is documented. So it's kind of like, it's useful. And for new developers, ramping up speed is increasing.
Yeah, it can definitely help new developers. And right now, we try to deal with this during code reviews, but it's not scaling. So
yeah, especially for community, it's going to be tough.
Yes. Other questions?
This might be more of a testacular question, but how does it compare to a test swarm? In the sense that I got the impression that they are similar.
Maybe Wojtek could come and talk. Test
swarm that
test swarm. This is what jQuery uses, right? So correct me, Wojtek, if I'm wrong, but test swarm is like a community crowdsourced solution for testing. It's not a system where you have a test runner running locally connected to all these browsers.
Right. Yeah, exactly. But to me, that's sort of I see that you went through the trouble of like going into the virtual machine and starting the browser only to have it talk back to you, and then so in the test form, all you have to do is like go random places and open the browser at the point to your server. Right?
But it's slow. Like
no. I mean the.
Can you run 1,800 tests in 3 seconds?
but I mean. So
it's yes or no. If it's no, then I'm not happy.
Well, you didn't talk about that part, but I understand that the way you do it is you send this JavaScript to the browser. That's the stuff that's actually running 1,800 tests in 3 seconds, and then you're sending the result back to the.
It's more complicated than that. There's a lot of stuff that Testacular does to make sure that tests run this quickly, and also watching the file system, like I demonstrated. It's not that I have to do something to run the test. I just make changes, save, and Testacular will just re-execute the tests in the browser.
I guess my point is that at the end of the day, all the browser is doing is opening this specific URL, and then things happen, right? Which is exactly what the test run does too.
Yeah.
So I mean, I don't see any reason why it can't run in 3 seconds.
Because. I don't think you can, but it's hard to discuss this.
Okay, thank you. Yeah. All right, that's fine.
I would be happy to be proven wrong, but.
You have to see more about how
Okay. Wojtek's here, so you can grab him and talk to him.
Yeah, do you have any story, example, or plans for a Maven plugin or integration otherwise?
No, but you can. You can contribute. We don't use Maven, so there's no reason for us to be doing anything. Like I don't like to do things just because they need to be done. I like to do things because they're useful for me and they solve my problem. Because if I'm not solving my problem, I don't think that I have the expertise to solve like the Maven integration or something. Because I don't use Maven. There are many people who do use Maven on a daily basis, and they have the expertise that is necessary for building Maven integration. So just by making all this stuff open source, it's not that difficult to just see what the shell scripts are doing, and you should be able to just create create Maven plugins.
Maybe one or two more questions.
Okay.
Yeah. And then back there.
If you're not using Maven, what are you using for your JavaScript build tools?
So right now we are building Angular using Rake, which is a Ruby's version of Make or Maven or Ant or what have you. And there is also a pull request plugin pending for switching over to Grunt, which is the de facto standard in the Node or in JavaScript community. But we are waiting for Grunt to release a stable version before we will switch over. So I like the pull request that is pending, and I communicated with the contributor who did a lot of really hard work, and it's awesome. But I want Grunt to be stable before we start depending on it. One last question?
Yeah, can I sneak in 2 questions actually? So
1.5.
Okay, they're related. So how many times do your tests fail based on the libraries that you depend on, and what's the one library that's giving you the most trouble?
So we optionally depend only on jQuery, and jQuery can give us headaches sometimes, but it's not that bad actually. Unlike when you're building web application where you have many library dependencies, I think our situation is very different. So it doesn't really, it's not a big deal for us. And the other half of the, or
jQuery is the one that would give you the most trouble if it did.
Yeah, so that's the only dependency that we really have, so yes. Okay, thank you everybody. We'll be around. We'll be around for some time. Come to us, ask questions. We'll be happy to discuss things further. Thanks for coming.
Don't go anywhere. I have a couple announcements. If you're taking the bus, as soon as I'm off the mic, come find me, and I will make sure that you find the correct bus to get back. If you've asked a question, see Chirayu, wave your hand. Chirayu's the newest member of the Angular team. He literally started today. But he's been at Google for a while. We're really excited to have him. And he has ownership of a bunch of t-shirts, so go see him, sign a release form, and get a t-shirt. We've also got some stickers, so even if you didn't ask a question, we have stickers. I have just posted the topic for the next meetup. It will be back here in a month. And the next meetup, our guest is going to be Ward Bell from IdeaBlade. And he's going to be talking about Breeze.js and Angular. So if you go to meetup.com, you can read the full abstract. And we should, if all goes well, be live streaming that one as well. So I want to thank everybody for coming out, and hope to see you at the next meetup. Is there going to be a San Francisco meetup soon? So a couple of people have been asking about San Francisco meetups. We tried really hard to get San Francisco meetup started, and we found that it kind of fizzled for lack of speakers. And we need an organizer who can be really active in terms of finding speakers and getting them out every month. And so if you are that person and you want to be the organizer for San Francisco, do talk to us. We would love to restart them. We're a Mountain View-based team, and it was just really difficult for us to keep it running from down here. So we're trying instead to focus on the live stream from here so we can get the presentations from the team out to as many people as possible, and also trying to get the Caltrain connector working as best we can so that we can get more people down here from San Francisco.
And some of us come from Santa Cruz.
And some of you come from Santa Cruz. Thank you for coming from Santa Cruz. We're very happy to see you here.